So thank you to Andrea for having the idea to invite me. Andre also already invited me before, so it's the second time for me here in ITB. Thank you very much, Andre, for receiving, and also thank you very much for the big attendance here, and I appreciate that the specialists of architecture and engineering are also interested in learning from bamboo. So my email, if you want to write me, is here. And the talk today is about, does bamboo offer something for business? Can we really make money with bamboo? How can we put a pricing? We saw already that Andre, where is Andre? Oh. So Andre was putting social price to bamboo, but social price is not interesting really for an engineer. Yeah, an engineer and architect, they also want to earn money, and I also did community work, and sometimes the community even doesn't want to work for free. They want to get paid. So sometimes it's difficult. So my search was finding a fair price, a competitive price. And my talk today is a little bit, is bamboo competitive? So if you have questions, the talk will be very long. So I find it more interesting sometimes to stop, and we have maybe a marker here, and I can quickly explain things. Maybe you can get another marker. And then if you have questions, I can explain. I assume it will be maybe 1 hour talk, but if we have interruptions, it will be 1.5 hours. But I think it's more interesting for you to ask the question when the picture is there. Okay? So this is the typical job description of a German carpenter. Yeah? Cell phone and computer. Before it was Girgayi and Paluvesa, but there is no really hard work anymore. Even nowadays you have women carpenters, because nowadays it's all about geometrical understanding, knowing the traditional joinery, and then you put everything in a special software, and the software designs these kinds of big buildings. This is a 20 by 20 meter. So imagine this is like 120 by 160 meter big roof in wood, laminated wood. And ITB is very famous because you have one of the very first laminated wooden structures in the world history. So I think it is very interesting for you to look into wood and also into laminated wood. I brought you here one of the very first, I think some of you also, you say in Java, there is also, this is from Indo bamboo. So this is artificial wood. And if you produce these kind of laminated woods made from bamboo, you can also make beautiful big architecture with this type of material. So, as we have so much computers nowadays, and even automatic prefabrication, so the computer chip, the disk, the hard disk, the CD, you take it out here, you put it in a big machine, and you put the trees in on one side, on the other side, all the little wood pieces with the perfect cuts, with the drilling, they come out perfectly prefabricated. So making one house is 1 day job. 1 day designing, 1 day prefabrication, and maybe 2 or 3 days constructing. So there is no more work for carpenters like me. And I have to go to Indonesia to look for a job. So I see you understand English. Okay. So obviously it is good to have practice. So I learned with Simon Welles. And Simon Welles in 1999 was building this building. It was a prototype scaled model for the World Exposition in Hanover. So I worked with him. I also did work before, but I learned a lot. For example, this building was tested. This was engineered, tested in a prototype. So they did cables from here to here and from here to here. They put a lot of load, and with the total station they were checking all the deformations, and later they put the AutoCAD design into the computer to calculate with SAP 2000 and to measure all the deformations and get conclusions about engineering capacity of bamboo. We know bamboo has a very big tensile strength, similar to steel, but the problem is in the joinery. So later we can talk a little bit about your, you were very honest, showing also the bad part of your construction, because only if we put the fingers in the wounds we can really learn. So making things, building, is a very dangerous job, because you are going to new terrain and you are making errors, or the Tukans are making errors, and you are responsible. You as an architect, you are responsible. So you have to learn first from the masters and then do your own job, but also be able to check critically what you have done wrong. But at the very end, you must put engineers to do the testing and verify if your SAP 2000 calculations are correct. The problem is not the bamboo, the problem is the joinery. Linda Garland, I think is also very important. I met Andri at Linda Garland, but I think you gave the introduction already. Yeah? So in Bali, you have now these types of buildings. Actually, I was in 2005 giving a workshop at Linda Garland's place. I think you were there, and also John Hardy was there. So he got very fascinated about bamboo. He did some traditional bamboo housing before, but now he started to do these crazy things. And I think nowadays, the world is looking to Indonesia and saying, wow, Indonesia is making wonderful bamboo constructions. And if I see your house, yeah, it's true. Yeah, it's beautiful. You have a big potential. There is a big potential. Only maybe 1% of the market. But there is a potential for guys like Andrea to go into the world, and for you, but you have a fixed job. But you there is a potential for all of you if you become a little bit practiced, practiced, and also visionary. There will be jobs, hotels, social work is always good for beginning, but you can't survive too much time on social work, yeah? Unless you become a UN consultant or something. That's good. So let's go on. There is also a second business line, export of poles. Indonesia is exporting a lot of bamboo hitam, a lot of bamboo petung, and also some other species, I don't know. But Christoph Tönges is buying 2 or 3 containers per year from Java. So there is companies in Germany that buy from Vietnam, from China, from Colombia, from Indonesia, from Africa. So inside Germany you can probably buy more species of bamboo, already preserved, dry, cleaned, but you pay $20 a piece. So I was selling 8,000 bamboo poles, perfectly graded, 12 centimeter on the bottom, 11 centimeter on the top, plus minus 5 millimeter. I sent 8,000 poles to make this parking lot. Sorry, this parking lot. This was 12 years ago. And the bamboo is a little bit gray now. Then they ordered new bamboo, and I think they will replace this bamboo, but they made a second parking lot. So in the city of Leipzig, there is a 4-story parking lot at the zoo made from Colombian bamboo. The structure is steel, but so the cars don't fall out and the children that walk there don't jump out. We had to cover this. And initially they thought in wood. But as it was the zoo, they think, okay, if we have the zoo with all these tropical animals, why not making the parking lot also a little bit tropical looking?
I saw so much green fungi.
Yeah, it's not fungi, it's actually moss. It's moss and lichens, because the winters in Germany are very wet, but it's only on the surface. You can take a power washer and clean it. The structure is still good.
Yes, I saw that. It's very, very still sturdy.
But because I have only used the bottom part, so I used the first 3 meters and the second 3 meters, nothing else. All the bamboo that was less than 1 centimeter,
the thickness of the bamboo.
And the matureness. I selected very mature bamboo, and that's why it's still there. If I would have taken every bamboo, problem. The main problem was the selection process and the drying. So I had to deliver very fast, and the bamboo was preserved. So you have a hole through it, you put it in a tank, and then it comes out with 150% humidity. So you must dry. And the drying was done like this. Yeah? So it becomes nice and yellow. But after 2 or 3 weeks here, you must put it in shadow. Like here it is in shadow, and there's always a stick between each line, so the air is flowing through it. But it was still too slow. Even Colombia is a tropical country, it was hot, but not hot enough. So I did this invention, I blow air through the hole. So the bamboo is actually drying from inside out, crack-free. Because if it dries from the outside in the inside is the water, and outside it's drying, so it's cracking. Yeah? But if you shrink in the middle first, the outside will be without crack. So I did this invention to the world. You can copy it. It's not patented, because I want bamboo to be successful. Yeah? Anyway, it would have cost $10,000 to make a patent on that, and I don't have it. But this is the way to do export in bamboo. So there is business, very occasional. The problem is Colombia, $500 a month for one worker is 3 times more expensive than Indonesia. But if you copy this system, Indonesia has a big potential for bamboo export. In Africa, we did the bamboo laminate fabrication, similar to the stick that is going around there. So these are Chinese machines. I worked several years for UNIDO, United Nations Industrial Development. So UNIDO is financing projects in certain countries, probably also Indonesia. You just have to ask. Maybe you just have to make a proposal, like ITB could make a proposal to UNIDO, not a private company, but an institution like your institution, and you can ask for machines. You write a nice project to German Technical Corporation or to UNIDO or to whatever is there. Yeah? Like in East Java, you can set up a factory, and you can, from here, you can train the people, and you get some machines here and some machines there. All this is possible. I've set up factories, like little pilot factories like this in 8 countries. Okay, also in Timor-Leste, for example, but not here in Indonesia. So what we are doing is this type of bamboo flooring. We cut split and make bamboo flooring. And another type of bamboo flooring is what you have in hand. You crush the bamboo and glue it together so it really looks like wood. There is no much difference between this and the traditional look of wood. And the specific density is more or less like 1 ton per cubic meter, or between 0.9 and 1.1, depending on the machinery. So the trick is to make splits, and then each kampong can have a collection center, and at the collection center it is prefabricated in splits. And then you send it to the factory, like Indo Bamboo or like this other factory you
Bambulogi.
Yeah.
Bambulogi.
Logi, yeah. So you can make blocks. And these blocks, every carpenter, every furniture maker can use this to make furniture. So before, Java was very famous for teak industry. You made thousands of teak chairs for the whole world. The logistics, the factory, the machinery is all there, but there is no more raw material. I think this, together with the 1,000 village program of like what Arif is promoting now, I think this is the future of Java and maybe Sumatra and maybe Borneo. So you see these type of machines, they are pretty big, but they are standard, traditional standard presses. It's nothing really nothing really different. In this factory, they do like Eternit, like the fiber cement, but before they were using asbestos, and now they are using bamboo fibers. So there is a percentage, 30% cement in weight, no, 70% in weight, 30% bamboo fiber. But in volume, it is 70% fiber, wood or bamboo, and 30% volume of cement. So maybe Institut Technical of Bandung has to do research on how to combine bamboo fibers with cement to make some Eternit kind, and then you get the press. It's about curing time, a little bit of vibration, a little bit of aluminium sulfate. You cook the bamboo fiber in aluminium sulfate, so the fibers go like this, and you have very good connection. So I think this is another possibility of working bamboo. So a different topic. Yeah?
For the bamboo boards, I have a question. So I tried already to work with bamboo boards made in Indonesia, but the problem was that it was just too expensive. So
Yeah.
I just found a few factories, and then the price for the material, the later board, was actually not much cheaper than teak wood, while in Vietnam or China, I get the boards cheaper than multiplex. So
not in China. Maybe in Vietnam you still get the same technology in Vietnam is applied now, but the quality is so shitty, you really are as bad as multiplex.
okay.
So the price relationship is very much with quality. China made a big error. For many years they were harvesting 3-year-old bamboo. Now they have recognized that for panels you must have 5-year-old bamboo. The specific density of the bamboo must be around 0.6 to process it. And in China you have big industry. You have maybe 80% of the entire village is working for bamboo. Some are using bamboo laminate, some are using the leaves, some are using the fibers, some are using the sawdust, so the 100% of the bamboo is going into production. If you start bamboo business in Indonesia, even the bamboo is cheaper here and labor is cheaper than in China, then you still have the problem that you have only one production line and one product. And 70% of the bamboo is becoming sawdust. So 30% become final product. 70% become bamboo sawdust. And that's where you lose money. It's the most expensive sawdust in the world. So I had a factory, I was doing bamboo laminates, and I produced at $2,000 per cubic meter. And China sells for $1,000 cubic meter. And maybe Vietnam even for less. Yeah? So laminate bamboo is very expensive. It's more expensive than teak. You are right. And this is the problem. But the future, like if you see here, this is sawdust. So if you have this machinery combined, go one back. If you combine this technology with the other one, then you are much better, because then you have a sequenced production line, you have different products, and it becomes organized and it becomes cheaper.
But even the bamboo boards I bought from China, the laminated one, the cross-laminated, are like 4 centimeter thickness, 240 times 140. It's just $15 to $20 a board from China.
Yeah,
so,
a board, but
one board.
calculate the cubic meter. The cubic meter is somewhere around $1,000.
Yeah, right. but like compared to multiplex or to a good multiplex, it's not that different. But then in Indonesia, the Indonesian produced bamboo boards are very different in terms of price. So why should I take bamboo then? Or how do I produce bamboo? I mean, I've talked to the factories, I tried to understand their way of production, and the thing is, of course, the labor is cheaper here than in China, but it's also way less efficient than in China.
So you have to work on the efficiency and you have to work on the big scale production, and it will become similar to China here. It's just a process of 10 years. You just started here. There are only 2 factories who make bamboo laminates here, and they are obviously much more expensive than big scale operations in China. China produces 30,000 square meter a month, one factory, and they have hundreds of factories. So the small factories in China went broke. They cannot compete with the big factories anymore. So there is a price fighting worldwide, and I think your error is that you are targeting cheap. You should target high-end market. You cannot compete plywood with beautiful, like normal ugly standard plywood is maybe $500 per cubic meter. You cannot compare with high density, high value, beautiful, clean surfaces like produced by bamboo laminate. So you're using a very expensive wood for cheap applications. You have to think, if you do bamboo boards, you have to think in high-end products. It's the same like softwood, like pine tree and oak, yeah? Or softwood from tropical and mahogany. You cannot do cheap houses with kerbau. Doesn't work. Yeah. Sorry. So go on. One step back maybe. There was one thing important here. If we get Borneo reforested, if we get a machine like this, we can finance the kampongs in Borneo to plant bamboo. Only if we are planting bamboo in big scale, the industry will work. And the other way around, only if we have industry, we can make the people in the kampong produce bamboo and sell it. So it's like what is first, the egg or the chicken? Yeah. So you have to see how you can join those two. The same like China. After Mao Zedong, China was a disaster. And then Deng Xiaoping, he organized China. He allowed a little bit of private industry to flourish. And nowadays, China is planting 50,000 hectares of bamboo every year. Because bamboo is recovering far faster than the hardwood. Yeah? So the chicken and the egg is the same problem like getting bamboo industry into process. But you are more architects. You are not into industry at this point. I just give you the vision. So there is one thing, can you go on? In architecture, if you build houses, like traditional houses, then you are also having high added value, because the perfect bamboo pole gives very high added value in very short time. With 100 poles you can make a 100 square meter house very fast. Yeah? But the 100 poles must be perfectly treated, perfectly straight. So maybe for 100 perfect poles you have 900 not perfect poles. So 900 poles go in industry and 100 poles go into architecture. So I see that the architecture is the flagship for the bamboo development, but the real money is not in architecture, it's in the big scale operation of industrial uses. So how can I make the capacity, the structural capacity of bamboo visible? I look into my own history. This was a 117-meter bridge, built 1760. This bridge was the biggest wood bridge ever built, before engineering was invented. Engineering came up with Gustave Eiffel when he built the Eiffel Tower. Yeah? He used French carpenters to build the shape, to give him an idea about how to structure the Eiffel Tower. So before Gustav Eiffel, there were carpenters who were able to do 117-meter bridges over the Rhine. And the guy who did this, Johann Grubenmann, he did not know to read, he did not know to write, but he knew mathematics and he knew he had a good crew of tucans. Yeah? And the diameter, the span, like here, 2 big cars of horses, carreta, yeah, can go through here. Very heavy, 50 tons each. So the old school is very important. Go. So what I do, I transfer old wooden bridges into bamboo bridges. And my specialty is not inventing bamboo or designing with bamboo. My specialty is the joinery. So all these little joints, they are very well thought through, because in Germany, the carpenter is not a designer. The carpenter is only responsible for the joinery, for the traditional execution of the joinery. That's our strength. The engineer designs, the architect designs, the engineer does the calculation, and they give us the responsibility for the perfect execution. This is something that has to be developed in Indonesia. You have to work together with the technical schools. So university is one thing, engineering is another thing, and you have to have the tucans trained. Otherwise you will have the same problems that Andrea was expecting, like this hook, the hook joint. It's bullshit. You can use it for furniture, but you cannot use it for structures. But you have to have the experience. So now he has the experience, and later he will do better. Yeah? So, go on. So we did this training. We did a 40-meter bridge. This was the bridge that was the inspiration for you. This is the 40-meter bridge in the University of Pereira. So our goal was to train the local tucans and the architects and the engineers, but mainly to get the combination, so architects, engineers, and tucans speak the same language. It's very important to get this working together, like a clock. Yeah? So it was actually very easy. Within 5 years, I developed a whole system. Like, this is a 5-meter module. So here you see it's only one cross. Here it's double, and here it's even triple. So I developed a modular system of designing bridges from 10 meters to 20 to 30 meters. What I could not achieve is to train the Colombians to use the bridge properly. So you see, here is a special joinery. I think this, you should study much more this little thing. There is a lot of going on. Like, for example, this thing is not slipping on top. There is actually a cut here, and it hooks into this. And there is all cement here, 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 here. Every little joint has a cement injection. Every joint with a 12-millimeter screw has more or less 2 tons of resistance. Yeah, I was very happy to see the Indonesian achievement, like 1910. This photo was taken. Java had a very outstanding bamboo construction history. This is great. This is tensile concept. This is a cable-stayed bridge. It's top engineering in the 21st century. How can we get this back into tensile structures? Yeah? It doesn't have to be exactly the same, but the thinking that was done in this bridge is extraordinary, and it's your cultural heritage. So pick up at that point. Go. This is another bridge. It was inspired by a footbridge in Germany. Professor Zengler, who was the most famous German bridge builder, wooden bridge builder, he made this triangular concept to put the trusses not squared, but to put them together in the middle. So he created a triangular cross-section of the bridge. Very clever. This guy made recently 80-meter bridge in wood. And I admire this guy, and I learned from him to think out of the box. So here we have tensile elements. I use the beton for the tensile elements and the hitam for the cross bracing, for the cross section. So the outside is compression, the inside is tension. And here you can see the joinery. The beton has very short nodes on the bottom, so you can always play with the beton to get the right distance. And on the top, you just leave it a little bit longer. This is a load test, but the Toucans had no problem, because the Toucans have built the bridge. They have full confidence. The next photo was much scarier. Yeah. This car is John Hardy's $80,000 Mercedes. When I asked him for the keys, he was sweating.
You drive this car?
Yeah.
Oh, great.
I drive it because I have confidence in the bridge. Because the Toucans weigh much more than this car. Yeah. Car is not a problem. Even on a footbridge, you have 500 kilo or 450 kilo per square meter. On a footbridge, 7 people, or maybe 6 of my size, yeah, are on 1 square meter. So if you have, for example, like in the bridge that we are doing in Medan now, yeah, like for the orangutan haven, there's nothing. If it starts raining, and we will have many visitors, they will all run on the bridge because it's the only place where there is a roof. Imagine if 1,000 people will stand on a bridge. That's easily 1,000 divided by, that's easily 20 tons of load on the bridge. This is the problem with the bridges. It's not possible to make a little sign, maximum 12 people. In the moment when it starts raining, nobody sees the sign. They just all walk on the bridge and they go for a bath. This is a very interesting flooring concept. You were saying that bamboo laminate is very expensive. I had the same problem. Part of it is the glue. The glue is a very high quality glue, so it's very expensive. So I use just the bamboo split vertically and put a pen through it. I call it pin boo. And this flooring is strong enough to distribute the load of the wheels of the car. No glue. Go on. Okay, so this is just design. Structurally there is not much going on here. The bridge basically is the arch, a little bit of distribution, and maybe a little bit of counterweight, because there is no cable. If there would be a cable, then you can say it's a cable-stayed bridge. But here we have just a little bit of cement, which is the counterweight to maintain this in the middle. This was the first bridge. Later they did a second one. It was not the original one anymore. And then John Hardy donated a house, and this house is standing on 4 points. The entire house is a little bit like Toraja, but the entire house has the idea of leaving the air out. And it's like a bridge, it's standing only on 4 points. So this is for the architects, just to inspire you that bridge is not everything, but you can also jump over from one theme to another and use structural concepts. Go on. Like you see here, I use the stair. The stair is coming here all the way down to the foundation, because the stair, go back. The stair starts somewhere here and goes to this part of foundation. So the very big cantilever of this roof is tensioned by the stair. So it's a little bit like a music instrument. Now there is a certain tension, inside tension on the bamboo. Okay, go on. Also the curve and everything. Everybody, every bole loved this. But the Balinese, they hate it. Balinese need squared houses. Maybe in Toraja you can make such a house, but you cannot make such a house for Balinese. It is against their world perception. It's just not possible. So I don't know if they still use it or if it's a museum now, I don't know, but they didn't like the house. Anyway, sorry. What is funny, Indonesia must have some kind of cultural heritage together with South America. How can it be that this bridge in Colombia has the same concept of tensile and the same concept of having, yeah? It is very interesting that Indonesian houses, like the Toraja house, also existed in Ecuador, for example. It is very interesting that this type of bridge is almost the same bridge like the Indonesian bridge that we saw from West Java. Yeah? So, I don't know, maybe something is there that we still have to investigate. So I took that bridge and converted this in a modern design. So this bridge has tensile elements, it has the bow. So here is the bow, and here are the tensile elements. So this is a 24-meter bamboo, but it has 8 meter here, 8 meter here, and then it starts 4, 8, 8, 4. So I'm overlapping the bamboo to make tensile elements, and the joinery is done like this. So I have a rebar inside. So I use this concept. What you have to do, you have to select the curved bamboo. When you buy it from the farmers in the field, you know the bamboo is like this. So you have to pay the farmer extra money to bring the very crooked ones and put it on a shipment. Normally they cut the crooked ones into short pieces because there are many crooked bamboos, but they cut them in pendek. Yeah. You have to pay extra money to get the very curved ones, and then you can make very good bridges. Yeah. They are there, but the farmers, they cut them in pieces. So I select, like look here, they're all very long. They're a little bit curved because they are for the arch that goes here. You see, there is a system, a coordinate system. I have line 0 here, line Y here, and each steel pin is from the coordinate system in my AutoCAD plan. I transfer it to the soil. So I can make this arch, I can make this arch, I can make this arch. Yeah? It's just exact 1 centimeter tolerance is the possibility to work that way. And it's a system. It's what carpenters do. Carpenters put something on the ground, they take the plan, they put it on the ground, and they work on the ground first, and later it is erected again. This is the trick to do big structures. At least it's my way. Go on. Sometimes we can press a little bit, and then I put bamboo pins. Every 50 centimeter I put bamboo pins to combine the... So you have, let's say in this case you have 3 bamboos, and then I put bamboo pins here, 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 and here.
Do you use steel rods?
Sometimes, for example, we use a steel rod. When the bamboo is actually not voluntarily, if it is a little bit up, and it's not really want to come down.
You use real bamboo pins?
I use bamboo pins in 80% or 90% of this is bamboo pins, but here and here you can see I also have every 1 meter or so I have a steel rod. Yeah?
What is the size of the bamboo pin?
12 milli. It's all.
Bamboo pins?
Yeah.
12 milli?
Yeah, I make them myself, dowels. Like I have a dowel machine, and all the bamboo that is like not usable for long elements, I cut in 1 meter 20 and make dowels. Okay. So you see the whole bridge is pre-assembled on the ground. That is very typical German or French or Swedish way of building houses. We do everything on the ground, and then with scaffolding or maybe with a little car crane, we just bring it up. This you can only do with bamboo. You could not do this with wood structures. Wood is too heavy, yeah? But bamboo is light. It's a lightweight construction. So the concept of construction is build on the ground and then use a crane or labor force like you did with your 100 Filipinos. You just put it there. Yeah. But these are old techniques. They are ancient techniques and they need community sense. You need somebody who gives the commando, or some have singing, they sing when they do community force, you have a rhythm, and with the rhythm you can actually very good coordinate the force. Next. You see? Next. Next. There's so much to explain, yeah? But you see here, I limited the width. The width of the road is only 3 meters. Because if I would make 6 meters, like now in Medan, we are doing 6 meter wide road, but then I have the danger of having 1,000 people on the bridge. If I limit the road, I have only 500 people. But the architect in Medan is a little bit stubborn. I told him to, but he wants to have a disaster, so I don't know. Load test, finished bridge, you see the anchoring. You see here is the tensile concept. This is converted into compression. That's why they are very strong. And here we have the...
Sure. I'm curious, how do you erect the curve when the road still normally used by cars?
How do I erect?
Select the curve.
It's already it's already selected. When the bamboo comes in, I have a truck with 200 bamboo. So 20 are very curved. 20 are a little bit curved. And 30 are straight.
No,
Do you put them all on the road? So do you stop the roads operationally?
Go back. Okay, one more. Yeah, stop. One more. Yeah. You see here is a scaffolding, and the road is free.
Okay.
Go back. One more back. Back, back, back. Back. Here. You see there is a bridge, like we call it a false bridge, and there is scaffolding under the bridge, but the road actually is going through here. But in Colombia we have a little bit of a problem which you don't have here in Indonesia. Colombians like to drink whiskey, and especially in this city we had an accident because some drunken drivers, they jammed into the scaffolding and damaged the scaffolding. The car, I don't care, but but it was strong. It was, even he took out the whole line of scaffolding, it was still strong. So the scaffolding was not on the street, yeah, but he was kind of.
I wonder how the durability of this bamboo, because it is not really covered by the...
Well, it's now 10 years, so you see some cracks here. Yeah. The cracks are basically from non-mature bamboo, especially petung. If petung is only 2 or 3 years old, you have lots of cracks. If it is 5 or 6 years, you have little cracking. The same with guadua. But the problem is the delivery is always late. The bamboo comes always green, and you have not really 100% selection. So always sometimes a little bit of unmature bamboo goes in the structure. But you have big packages here. We have 3 meter span from here to here with the roof. So it's more or less 3 meter here, and the bridge here is wider, but you can also see that the roof is wider. So we have sun coming to the, which is actually causing the cracking. But then I have a very good coating It's like Livos deck oil. It's very good coating. Also, we used it in Phuket, in Thailand. It's
Is
one.
it available here in Indonesia? Have you find it?
Well, there is a distributor in Bangkok. He sends also to Jakarta. I don't know.
What is it?
I can Livos. Livos. It's called Alice deck oil. Alice deck oil.
Alice deck oil.
It's very good. But I think you have also local products here that are good enough. Anyway, it's just a question of coating. So here you see that there is, the sun is now coming from the side, but there is, I put these two additional, normally it would go like this, but then I would not have enough shadow. So I introduced 2 extra points to have the, and this roof shape is actually inspired by Indonesia, because before coming to Indonesia, all my bridges were straight and squared. And I learned in Bali, actually, I learned that a little bit of, like also the Batak houses and the Minang houses, they have this, so the hot air inside is always going out. Yeah? So I love this inspiration here from this style of roof. Here in Vero Beach in Florida, we did this to leave the air out. So this is a little bit more like Javanese Joglo style. But it was the first building in United States. This is the first building in United States with full certificate, like engineers signing for a bamboo building in the United States. So that was a big achievement in 2004. And a hurricane came in 2004, a hurricane just after finishing the building. Hurricane Rita came and wiped out all the trees. So all the trees that are here are not anymore. But the bamboo building only left 25 fans, because there is a special technique that the Indians use for centuries to nail the bamboo, the palm fan, the thatch is nailed in a special technique, and they can withstand hurricanes.
You mean Indian, American Indian or Indian?
American Indians. This is another development. Actually, bamboo is very straight, sometimes a little bit crooked, but not really curved. So at John Hardy, we played around because he's a jewelry designer, so he wants to make everything like this. Yeah? It's not possible. Well, it is not possible, or do I have a limitation in my brain? Yeah? So one day I was seeing a whole pile of bamboo, because we always work with the bottom part. We never work with the top part. But the providers were also sending the top part. So the top part, the tip, or how you call it, the ujung, yeah? It was always piled up there. So how can I use this? So then I came up with a book about Japanese architecture and Japanese gardening. And they have something they call tamabuchi, which is like a broom, like a lidi. So we cut all the bamboo into 1 centimeter, like pencil size sticks, and join them together here with bamboo, with tali. And then you can actually bend. You can see here, it's all bent. You see, it's like a big rope. Or here. So using all this bamboo lidi, we discovered a completely new system of construction. Actually, it is not very good in flexion. Yeah, it's only good in tension. So, but if you put some bamboo split inside the lidi, then it becomes strong. Or you can put a smaller bamboo inside, and then you can bend it, and it's still strong enough.
Can you tell us how to bind those small lidi bamboo?
Go back to the 2 or 3 photos back. Here.
Yes.
So I take a Spanish wrench. So I have maybe 100 split, like very 1 centimeter by 1 centimeter. Then I take a rope and this.
Rotten or what?
No, this is meat. This is. They use bamboo tali. You can cut and you can make bamboo tali out of it. That's why it's called bamboo tali. You can make a rope out of bamboo. So this rope you can buy, and then first I press the lidi really strong with the rope. I twist it. I pressed it. Then I put the tali around with a little bit of lem, a little bit of glue. You press it around, and then you release the Spanish wrench, like the, and then you have the system.
You construct it on site or on the ground?
We prefabricate in the factory, and then 20 people walk it to the site.
How do you?
No, you can form it when you can form it in the place. First you make one straight lidi, and then you just twist it. It's very creative, actually. It's very interesting. They use it a lot in green school. It's one of their biggest secrets. But it's very easy. You just have to try. Okay, this was the three Agung, Batur, and I don't know the other one, I forgot. So the three mountains of Bali, the three volcanoes of Bali, they became the three mountains, and I think to relax a little bit, you tell the story about Tiga Gunung. So it was a football field, like 50 by 25 meters, or sometimes 27, 3 towers, and I copied the concept of the volcano. So inside, go on, one more. Inside you have this tower. So I have a ring formation on top, a strong ring, laminated bamboo ring, and on the bottom I have another ring, and I have these V-shape version, yeah? And I have tensile elements that go vertically. So one outer ring, one inner ring. This is compression, this is counterweight, and then we go on. Then we put the rafter from the top ring to the bottom ring. And I think now you can explain your... Because this is the first building that has been recycled. After 7 years they needed a new roof, but the world economy was not so good, so they decided to sell the whole building. And the whole building was transferred to Turtle Island. So the whole tower was calculated for 40 tons of weight. Because if the alang-alang is getting wet, it will have 40 tons on each tower. Nevertheless, we never had a problem with this system. So it's very strong, very interesting. Because nobody sees, you cannot see, if you have Moore, everybody says, engineered structure, very clever, yeah? But now people come there and they don't see actually how this thing is working. Yeah?
Is that your reason for choosing the bamboo?
Is to confuse the engineers. Yeah.
Steel rods?
You can use steel rod also. You can use steel rod
Was
and
that
cut.
your reason to use the bamboo instead of steel rods?
Sometimes if I know where the force is acting and I know there is a lot of force, I still use steel rods in the same system, yeah, and cut here because it cannot come out. But if the force is only around 300 kilo, I can use bamboo. I don't need to use steel. But if the force is like 2,000 kilo, then I have to use steel. So this is a little bit of the effect. You have this compression, tension, tension, and here you have the compression. Yeah? And on the top, I have a skylight. But the roof of the skylight, the glass, is like 30 centimeter higher than the roof. So air, hot air is building up, going and going out. So this thing, go one more photo. You can see the air is coming in and going out. It's very nice natural air conditioning. Nowadays you have meteorologists. Where is he? The engineer meteorologist. Huh? This is one of the most amazing discoveries. Green school doesn't need aircon. Yeah? It's natural aircon. So you tell me the story about Professor Neuhoff. He came to do the engineering, or you don't know too much about it?
I don't know too
Okay.
much about it.
So one of the professors that is working together with Andri in Germany, he came with a student group and he wanted to see a bamboo building. We were just doing this, and we were needing engineering, because you know the authorities, they always want to have a sign of an engineer. So no Indonesian engineer was really willing to sign off. Understandable, because you are responsible, you go to jail. Although you have a very beautiful jail here.
I passed him to Lapas Sukamiskin with a very big
I think it's better to stay out. Anyway, so this Professor Neuhoff and the German students, they took some measures. You see here, this barrel was actually hanging on the roof, on the rafters. And there's 200 kilo of water here, 200 kilo of water. So in total we have 5 barrels, 1 ton of water. Yeah? And then the roof came down 16 or 17 centimeters. And at the same time, when the roof comes down, it goes a little bit like this. So basically the span here expanded like 3 or 4 centimeters.
Yeah.
So these measurements, they were taken and then they brought this to Germany. And when they came to Germany, they noticed that their Sabtu 2000 didn't have enough capacity to calculate all those elements, because there were like 500 elements in this. Yeah. 500 elements means probably 1,000 joints. So they didn't really have the software to calculate it. So it took about a year until they get financed a new software. They bought the most modern software. They put this whole building in the software, and they calculated the stresses in each point. Wonderful, wonderful graphic. But for me, the most important thing was Professor Neuhoff called me and said, "Jörg, I must congratulate you. Your gut feeling was just 3% different from the ideal point of building this structure." So for me it was a very honorable comment, because from experience of 20 years working with bamboo and wood, I could mostly predict not only the bamboo but also the strength of the joinery. Because as I told you, we have to work together. Architects, the concept, the engineering, the execution have to be perfectly executed. Go on. Yeah. So bioclimatic architecture has been done in centuries ago. Like these houses are ceramic houses. They are for incense. I don't know what incense. You have also incense here, like smoke, like sandalwood. So the ancient Ecuadorian people, they made these little houses to smoke to the gods and to pray and everything. But look the shape of the roof. Typical tropical architecture. Nowadays in the tropics, everything is squared and a zinc roof on top. This is the architecture of today. And before, this was the architecture. And I think this is very similar to Batak or Karo, and it's very similar also to Toraja. Yeah? So maybe there is some connection between Indonesia and Ecuador. But no. So I was building a house there with the same system, prefabricating like big A-frames, and we use the bamboo as scaffolding. Go on. So later, when you finish the house, you take the horizontal beams out. But the house is standing on four. The house is standing on 4 beton pillars here. So my proposal was this should be the architecture for tourism industry, because this is ethnic identification with cultures that have been in Ecuador 3,000 years ago. They have bioclimatic aspects, they have cultural aspects, they have natural materials. For me as a tourist, I would go here. I would not go to a standard square box, 7-story tourist hotel. Yeah. So my proposal after the earthquake, we just did this. We trained the personnel, we trained the local carpenters, but we also gave them a new idea about their own culture. It was completely forgotten, nobody knows. Very similar, this is Sumatra. This is relatively traditional carpentry. Yeah. It is done in bamboo, beton, 12 meters, 2-story building. It's all prefabricated on the ground, so the whole truss is completely screwed together on the ground, and then up. Go on. It's a little bit resembling the bamboo, like it's growing. Go on. So this is Lusa National Park, the orangutan conservation, and this was a spiral tower built as a sculpture for a rock concert or a jazz concert. We did a jazz concert at the Panama Canal, and this is just some crazy stuff. It only will last 6 months or so, and then next one. But it's also something that can draw attention. It will give it will call for attention. People in Panama will say, "What is this?" Yeah. Okay. So some books. The most important books, in English at least, Bamboo EL31, Gift of the Gods from Oscar Hidalgo. It's looking to thousands of constructions all over the world, and Bamboo Construction Manual from Gernot Mielke. My email, and that's it for now. So now we can have a little bit of discussion. Or rest, maybe a cigarette or coffee or